Hey everybody, today I wanted to start a little series on the introduction to set theory. So I want to teach you guys about sets and what you can do with sets and just some cool things in general about them. So let's just start with what is a set. Well, a set is just a collection of elements. Pretty much a set, anything that you see, like you can think of a television set or a set of people that like the color red, stuff like that. Anything that has to do with a collection of objects is a set, right? So in math, it's pretty much the same thing. There are a list of axioms that a set must follow. I'm not going to go through them in this video. I'll probably go through them later on, or I might not even go through them, I don't know. But those are just very specific things about sets. If you're interested, you can look up the Zermelo-Fraenkel axioms of set theory. That you'll see all those axioms and stuff like that. There's probably a Wikipedia article on that, so you can go through that. But really, I just want to tell you what a set is and a few things you can do with them in this series. So, a set can very easily be represented by just like a circle or something, right? So here is my set. I'm going to call this set capital S, and I'm going to include a little element in here. And this element I'm just representing by a point. I'm going to call this x0, right? And then we can have another element in here. I can call this one x1, and then I can have another one, we can call it x2, right? So these are my three elements in the set, and the way we say that an element is in a set, basically we just say x0 is an element, which we denote with that little weird symbol there. It kind of looks like the euro sign, kind of looks like an E, I don't know. X is an element of S, right? An element is just another word for member, so x0 is a member of S. Same thing with x1 and x2, they are members of S. Okay, well what if we had a subset of our set? So a subset we can denote by another circle. Let's say we had a subset here. I'm going to call this subset, I don't know, A, right? So if I want to say that A is a subset of S, I would say that A is a subset of S, like that. Now there are some notations, there are some different notations of subsets versus proper subsets. A subset just means it's included inside of that set. And a subset could actually be equal to the set. So S itself could be a subset, right? But what if we don't really want this? Sometimes we don't really want this to be the case, so we will say that it is, so we'll talk about the idea of proper subsets. So a proper subset just means, it means the same thing as a subset, just not with this last thing, okay? Now there are different notations that you could use for that. Like I said, I prefer having something like this mean subset and this mean proper subset. So let me get rid of this. So this means subset and this means proper subset. Now, you just have to be careful with the notation because different authors use different ones. I like this because it's kind of like the less than or equal to or greater than or equal to signs, and this just means it's like not equal to, right? So, I don't know, you can choose whatever you like. Now, so what exactly is a subset? Because we talked about what a subset is, and it should make sense to you, something being inside, like one set of things being inside of a bigger set of things, or one that's equal to that same size. So really a subset is we can say that, we can say A is a subset, I'm going to call this my subset, A is a subset of S if for all elements, I'm going to say Y, for all Y inside of that set, which side? Inside of A, yeah. if for all elements y inside of my set A, so every element in here, so if that's true, then y is inside of S, right? So I'm saying that if y is in A, so every single element in here has to be inside of S, right? But it's only those elements. It can't be any other element. So if A kind of, takes a detour and decides to be like, oh, let me just go like that, it's no longer a subset because like this element in here is not included in S. So A, and so this is if and only if, actually. So this would be if and only if, right? So this is like a double implication. Basically, you have to meet this condition and only this condition so that that is a subset. So if you have any other elements outside of it, it doesn't work. Okay, so let me clean this up again. So let me just cross that off, and then let me just, there we go. All right, so that's basically how that works. So that's what a subset is, okay? And so we talked about elements, subset, introduce some notation. Now let's do some other things with sets. What if we take two sets? So let's say yeah, we have a set. Actually, I don't want to use A for that, but whatever, we already did. Let's say we have a set capital X and a set capital Y. And you can see that they're intersecting together. They're just, part of it is inside of the other, but they're not subsets of each other, right? Because they're not entirely contained within each other. So we have these two sets, X and Y, that have a place where they intersect. So there are two basic notions that we can talk about. There is the actual intersection. This is the intersection. And there is the union. Okay? So the intersection is just this portion. Just that. Basically, it's all the elements that are both in X and Y. So actually, let me erase this for now. So we denote the intersection as X like that, and this will make more sense in a little bit of why it's this upside down U-shaped thing. But that's what that is, and it's just this part. So it's all elements. So it is. So I can say that this is equal to the set for all elements. I don't want to use X or Y again. Let me just say Z. All elements Z, such that Z is in X and Z is in Y. Okay. And it has to be both. That's why I'm using the word "and" here. And I forget the logical symbol, if it's like lowercase, or if it's like this, like this, or like this. I forget which one it is. But yeah, so it has to be in both. So that's why I'm using the word "and." Okay. This will make a little more sense if I introduce a union. This is denoted X, U, Y. And make sure this U doesn't look like a capital U. And that's because we don't want to, because sometimes a set can be capital U, so we don't want to confuse anything. So if you're doing a capital U, maybe it's best to like do it like this or something. I don't know. I just make it substantially larger for me, because I prefer writing my U's like this. So just make it like substantially larger, and it should be okay. Or just use like a curly U. You can do something like this if you want. I don't know, up to you. But yeah, so the union is the whole thing. So it's going to be all of this. And pretty much, yeah, so it's the entire set. It's taking those two sets and combining them into kind of their own set. And so X union Y is equal to all elements Z, the set of elements Z such that Z is in X or Z is in Y. Now, or in math just means one or the other or even both, right? So any element, let's say my z is in here. It is in x, but it's not in y. So it's not in the intersection, because for it to be in the intersection, it has to be in both. But it is in the union because it's in x, and that is either x or y or both, right? So it's in at least one of them, so it satisfies the or property, and therefore it's in the union. So that's pretty much intersections and unions. Now there is the idea of like intersections of a lot of different sets, or the unions of a lot of different sets. So if we have something like the union of, this might be scary, or I'm sorry, this is the intersection of like I in, let me just say it's like I equals 1 to 10 of, I'm going to call these sets, I don't know, B, so B sub I. This just means, B sub 1 intersected with B sub 2, intersected with so on and so forth, all the way to, let me not put the dots there, all the way to B sub 10. So it's all these sets, B1, B2, B3, all the way to B10, intersect all of them, and that's what that is equal to. Same thing for the union, you just replace the symbols. And you can have infinite intersections or unions as well. That's a whole different monster there. But yeah, I just wanted to give you guys the basic ideas of sets. This isn't really that basic, but I just wanted to show you that yes, there is a notion like that. It's very analogous to the way you have sigma from like I equals 1 to infinity or something like that. So yeah, I talked about basic idea of like what a set is, elements, subsets, proper subsets, intersections, unions, and some other things mixed in. So I hope you enjoyed, hope you learned something new, and I'll see you in the next video. Bye guys!